Okay, continuing to talk about rational expressions, a couple of terminology points here. A lot of times directions are going to say things like uh, express this expression in simplest form or lowest terms. So all we mean by simplest form and lowest terms is that you've canceled out all common factors. So there will be no common factors between the numerator and the denominator, except of course 1. That's always going to be there as a common factor. -1 as well is always there, and we'll actually see what we mean by that right now as we talk about opposite factors. So this is a bit of a subtlety for us to watch out for. So if I were to say I have the number 3, what is its opposite? And you all said to me -3, right? What we mean with the word opposite is exclusively on opposite sides of 0 on the number line. So that only means changing the plus or minus sign. That becomes a little bit more complicated if we look at binomials. If we take a minute, -3 really is just -1 times 3. So opposites essentially differ only by a factor of -1. So when I talk about a binomial, if I were to say, for example, a minus 2, its opposite would be -1 times a minus 2. Well, you notice if I distribute that, this gives me -a plus 2, which could be more easily written as 2 minus a. And let's make an observation here. This means that a minus 2 has an opposite of 2 minus a. So these two expressions here are opposites. But let's make an observation here. This means if we were to take 3 divided by -3, these two are opposites. When we divide opposites, what's our result? Of course, -1. That means the same would be true if I were to divide these opposites. A minus 2 divided by 2 minus a leaves -1. This is really important because it means now when I see opposite factors in a rational expression, I can cancel them and just make sure I leave a -1 behind for one of those two factors. Remember, the two of them are canceling each other to leave one -1 factor behind. So when I see opposite factors in a rational expression, we can cancel and leave a -1 behind. Let's see that in action on a couple examples. If I were to look at, say, 2 minus a over a squared minus 4. We just said in the previous video there are 2 steps for simplifying a rational expression. Those 2 steps are factor and cancel. So this 2 minus a, there's no factors, no common factors. I can leave it as 2 minus a. But in the denominator, a squared minus 4, hopefully recognize right away, is a difference of 2 squares. So we have a plus 2 times a minus 2. And now notice, we don't have any exactly common factors, but we do have opposite factors. 2 minus a and a minus 2 are opposite factors, just like we saw right here. And so when we see opposite factors, we will cancel them, but instead of leaving +1 behind, we'll leave -1 behind. So this leaves us with a final answer of -1 over a plus 2. And that's our final simplified expression. We would, of course, make note of any undefined values. We can see here that if a were -2, that would cause the expression to be undefined. Or if a were +2, that would cause the expression to be undefined. So we'll exclude those both from our answers. Okay, let's look at just one more and then I'll be done for the day and you can maybe work on some homework. Suppose we had 8 minus 2x over x squared minus 8x plus 16. Feel free to go ahead and work ahead of me. But let's look at this. If there's a rational expression that we're trying to simplify, we know that there are 2 steps to simplifying a rational expression. Those 2 steps are all together, we said, factor and cancel. You sound beautiful. Okay, so we're going to factor the numerator and factor the denominator. 8 minus 2x. First rule of factoring says to take out the greatest common factor. That's 2. And it leaves 4 minus x. And that is all over in the denominator. Hopefully we can factor this trinomial quickly and see that it is x minus 4 times x minus 4. And again, there are no actual common factors here, but we do see a pair of opposite factors, right? 4 minus x, and then we see 2 instances of x minus 4 in the denominator. It does not matter which one you cancel, but you should only cancel one of them. We can't cancel both of them. We always have to cancel from the numerator and the denominator in pairs. So we see 4 minus x cancels x minus 4, but because they're opposite factors, that's going to leave a negative 1 behind. All right, so then in the numerator, let's multiply our remaining factors. We have 2 times the remaining factor of negative 1 makes negative 2 in our numerator. And the denominator, all we have left is x minus 4. And that is our simplified expression. We would again note any values that cause the expression to be undefined. The only one that would cause the expression to be undefined would be x equals 4. So we'll make sure to note that x cannot equal 4 in our simplified expression. All right, so there's the basics of simplifying rational expressions. You're going to practice that a bunch tonight, maybe some more tomorrow in class. This is a really crucial skill. As we go through the whole chapter, all of our expressions and our answers need to be left in simplest form or in lowest terms, so we need to make sure we always end the problem by simplifying the rational expression. And now we have the basics there. 2 steps to simplifying a rational expression. Every time, always, factor and cancel.